Drift gently now into this moment, this very breath, as you find yourself lying beneath the vast canvas of night. Feel the soft grass beneath you, still warm from the day's gentle sun, and let your eyes slowly open to the infinite tapestry above. With each breath in, you gather the silvery light of distant stars. With each breath out, you release yourself into the peaceful darkness that cradles our world. Here you are, a gentle soul gazing upward, at the same magnificent display that has welcomed countless generations before you. Imagine the ancient shepherds in distant lands, their fires crackling softly as they watched these same stars wheel slowly overhead, patient as breathing. Picture the Chinese astronomers of centuries past, drawing their delicate star maps with brushes dipped in midnight ink, each constellation a story whispered across the flowing river of time. Feel the presence of Polynesian navigators, floating peacefully on moonlit seas, guided by these celestial lanterns toward distant shores, where new stories would unfold like flowers opening to dawn. As you breathe deeper into this starlit peace, notice how the sky seems to pulse gently with ancient light. Each star is a distant island of fire, floating serenely on an ocean of velvet darkness. Some shine with the soft blue-white glow of youth, others with the warm amber radiance of peaceful maturity. Between them flows the gentle river of the Milky Way, our cosmic home, streaming across the dome of night, like luminous silk scattered by tender hands. You are part of this flowing tapestry, connected to every gleaming point of light by invisible threads of stardust and wonder. Let your consciousness drift softly upward now, floating gently through the atmosphere like a feather carried by evening breezes. Feel yourself rising peacefully above the familiar landscapes of Earth, where city lights twinkle like scattered diamonds and moonlight paints silver paths across sleeping oceans. As you ascend through the thin boundary between our world and the infinite beyond, notice how time itself begins to slow and stretch, like honey flowing from a warm spoon. Here, at the threshold of space, you can feel the patient pulse of cosmic rhythms that have been breathing since the first moment of creation. The darkness around you is not empty, but full of gentle possibilities. It whispers with the soft background radiation that has been flowing through the universe for billions of years, a cosmic lullaby that sings of ancient beginnings and patient transformations. This is the afterglow of creation itself, cooled now to a temperature barely above absolute zero, yet still carrying the memory of that first flowering of light and matter. You float peacefully within this ancient song, feeling how your own body carries elements forged in the hearts of stars that lived and breathed light long before our sun was born. As you drift deeper into this cosmic embrace, consider the magnificent journey that brought you to this moment. The calcium in your bones was crystallized in the gentle cores of ancient stars. The iron in your blood was stirred slowly in stellar cauldrons, patient as seasons. The oxygen you breathe was exhaled by massive stars in their final graceful transformation, gifting the universe with the elements of life itself. You are literally made of star stuff, a walking constellation of ancient light temporarily gathered into the beautiful form of consciousness that now gazes peacefully upward at its cosmic ancestry. Time moves differently here in the embrace of infinity. Minutes flow like centuries, and centuries pass like heartbeats. You can feel the Earth turning gently beneath you, carrying you on its patient journey around our local star, the Sun, which itself dances slowly through space with hundreds of billions of stellar companions in the great spiral we call the Milky Way. This galaxy, in turn, drifts peacefully through the cosmos, along with trillions of other island universes, each one a collection of stars and planets and possibilities beyond imagining. The ancient light that reaches your eyes has traveled for years, decades, centuries, millennia to arrive at this perfect moment of connection. That gentle star shining softly above your right shoulder. Its light left home when your great-great-grandparents were young, journeying steadily through the darkness to meet your gaze tonight. The distant nebula, those cosmic clouds glowing like celestial flowers, are stellar nurseries where new suns are born in processes so gradual they unfold over millions of Earth years, patient as the growth of mountains. As you float in this sea of starlight and possibility, you can sense the vast story that connects every shining point above you. Each star has its own biography of birth and growth and eventual transformation. Some are young and hot, burning their fuel with the bright enthusiasm of cosmic spring. Others are ancient and red, having settled into the contemplative autumn of stellar life, glowing with the warm wisdom of ages. Still others have completed their stellar journey, having gifted their substance back to the cosmos in gorgeous displays of light and energy, seeding space with the elements that would eventually become new worlds, new possibilities, new consciousnesses like your own. Feel how your breathing synchronizes naturally with these cosmic rhythms. Inhale the ancient light, exhale into the patient darkness. Your lungs expand and contract, like stellar nurseries breathing with the slow pulse of creation. Your heart beats with the rhythm of binary stars dancing around each other in gravitational embrace. Your thoughts flow like solar wind streaming gently from the surface of stars, carrying information and energy across the vast spaces between worlds. The night sky above you is a living library, each constellation a chapter in the greatest story ever told, the biography of the universe itself. The Big Dipper pours starlight like water from a cosmic ladle. Orion the Hunter strides eternally across the winter sky, his belt marking the position of stellar nurseries where new suns are being born even now. The Summer Triangle marks the meeting place of stars from different eras of cosmic history, their light mingling in the sky like voices in a celestial choir. In this gentle moment, suspended between Earth and infinity, you can feel yourself as both infinitely small and magnificently vast. Small, because you are a single consciousness on a modest planet orbiting an ordinary star in the outer reaches of a typical galaxy among billions. Vast, because you are the universe becoming aware of itself, a collection of cosmic elements organized into the miracle of consciousness that can contemplate its own origin and destiny. You are the cosmos, awakening to its own beauty, the universe learning to see itself through eyes made of ancient starlight. The temperature around you is the perfect coolness of a summer evening, warmed by the gentle heat still radiating from the earth below, and cooled by the infinite depth of space above. This temperature, approximately 2.7 degrees above absolute zero, is the temperature of the universe itself, the cosmic background radiation that fills all of space like a gentle thermal blanket. It is the echo of creation, cooled by 13.8 billion years of cosmic expansion, but still present, still singing its ancient song of beginnings. As you prepare to journey backward through time, let yourself settle deeper into this floating peace. Feel how your consciousness can expand to embrace vast scales of space and time while remaining perfectly relaxed and centered. You are about to witness the greatest story ever told, the biography of everything that exists. And as you drift gently backward through the flowing river of time, remember that you carry within your very atoms the memory of every moment you are about to experience. You are not just observing this cosmic story, you are its living expression, its consciousness, its capacity to wonder at its own magnificent unfolding. With each breath now, feel yourself drifting further back through time, beyond human history, beyond the age of our planet, beyond the birth of our sun, back toward the moment when the first stars began to shine, and further still, toward the gentle dawn of everything. The darkness around you grows softer, more luminous, pregnant with the infinite possibilities that gave birth to all the wonders you have just witnessed. And as you breathe deeper into this cosmic cradle, you feel the first gentle stirrings of the story that would create not just the universe, but you yourself, a conscious being capable of contemplating the very mystery of existence. And as you breathe, we drift together, back beyond memory, beyond story, beyond the familiar boundaries of time itself, to witness the gentle flowering that would become the entire cosmos, including this very moment of peaceful contemplation beneath the star-jeweled night. Let us journey now to the beginning of beginnings, where silence learned to sing, and emptiness discovered the art of becoming everything. Drift now through the most profound stillness imaginable, a silence so complete it contains within itself every sound that will ever be. You float in the perfect peace that existed before time, before space, before the first gentle breath of creation. Here, in this infinite moment of potential, everything that will ever exist rests in patient waiting, like seeds sleeping peacefully in the dark earth of eternity. This is not emptiness, but fullness beyond measure, a single point containing infinite possibility, warm with the promise of all the stars, all the worlds, all the consciousness that will eventually flower from this perfect seed. Feel yourself cradled in this boundless potential, where the concepts of here and there, before and after, have not yet learned to distinguish themselves from the eternal now of pure being. And then, with the gentleness of dawn breaking over still waters, the great opening begins, not with violence or chaos, but with the soft exhalation of infinite love learning to express itself in form. Like a flower blooming in slow motion, space itself begins to breathe into existence, each moment of expansion as natural and peaceful as your own breath filling your lungs. The universe does not explode into being, it whispers itself awake, stretching gently like a sleeper greeting the morning. In the first trillionth of a trillionth of a trillionth of a second, a time span so brief, It makes the flutter of a hummingbird's wing seem like an eon. The infant cosmos grows from smaller than a proton to the size of a grapefruit, its expansion driven by a field of energy so perfectly smooth. It would make the surface of a calm lake seem rough by comparison. This is inflation, the cosmic equivalent of a gentle breath that carries the seeds of all future galaxies to their appointed places in the vast garden of space. As this primordial breath continues, the temperature of this newborn universe gradually cools from the infinite heat of pure potential to a mere trillion degrees, still unimaginably hot, yet already beginning the patient journey toward the coolness that will eventually cradle planets and life and consciousness. The cooling is as gentle as evening settling over a summer landscape, each degree of temperature a step toward the complexity that will bloom in ages yet to come. Within this expanding ocean of energy, the first fundamental forces begin to distinguish themselves, like instruments in an orchestra finding their unique voices while remaining part of the same cosmic symphony. Gravity, that most gentle of forces, learns to embrace the strong nuclear force, discovers how to bind. The electromagnetic force begins to weave its patterns of attraction and repulsion, and the weak nuclear force starts its patient work of transformation. They emerge not through conflict, but through the natural differentiation of infinite potential expressing itself in diverse forms. As you float through these first moments of existence, you can feel the profound silence that still underlies all creation. The universe has not yet learned to make sound. There are no molecules to carry vibrations, no ears to hear, no consciousness to listen. Yet beneath the silence runs a deeper music, the harmonic frequencies of fields and forces learning to dance together in perfect coordination. This is the music of the spheres that ancient philosophers intuited, the underlying rhythm that will guide the formation of everything from atoms to galaxies, to the neural networks that allow you to contemplate this very moment. The light that fills this early universe is unlike any light you have ever seen. It is not the gentle sunlight filtering through leaves, or the warm glow of candle flame, but the pure luminosity of creation itself, photons of energy, bouncing freely through space, carrying information and warmth throughout the cosmic ocean. This primordial light is so energetic that matter cannot yet hold together in stable forms. Particles appear and disappear like waves on the surface of an infinite sea, their brief existence adding texture and complexity to the expanding tapestry of space-time. As the universe continues its gentle expansion and cooling, something miraculous begins to happen. At around 1 second after the great opening, an eternity in cosmic terms, the temperature has dropped enough for the first stable particles to form. Protons and neutrons begin to condense out of the energy field, like dewdrops forming on morning grass. Each one a tiny seed of the matter that will eventually become stars and planets, and the very atoms of your body. These first particles are the cosmic equivalent of hydrogen nuclei, single protons floating in the vast ocean of space, accompanied by smaller numbers of heavier nuclei formed through the gentle fusion processes of these early moments. About 75% of all normal matter becomes hydrogen, 25% helium, with trace amounts of lithium, the three lightest elements that will serve as the basic ingredients for everything that follows. Think of them as the primary colors from which the entire palette of the cosmos will eventually be mixed. For the next 380,000 years, a mere moment in cosmic time, yet longer than all of human history, the universe remains filled with this glowing plasma, too hot for atoms to form, too energetic for light to travel far without scattering. It is like being inside a luminous fog that fills all of space, a gentle radiance that touches every point in the cosmos with equal warmth. You float peacefully through this era of cosmic dawn, feeling the patient cooling that will eventually allow complexity to emerge. The expansion continues with perfect steadiness, driven by the initial impulse of that first gentle breath, and guided by the mysterious dark energy that comprises most of the universe's substance. Space itself grows larger, carrying the matter and energy within it, like passengers on a slowly expanding balloon. But this is not movement through space. It is the growth of space itself, as natural and inevitable as the unfolding of a flower toward the light. As you drift through these epochal moments, you can sense the infinite patience of cosmic evolution. Nothing is rushed, nothing is forced. Each development follows naturally from what came before, like notes in a vast musical composition, where every harmony emerges at precisely the right moment. The universe takes its time, knowing that the beauty it seeks to create requires eons of careful preparation and gradual refinement. The temperature continues its slow decline, 1 billion degrees, 100 million, 10 million, gradually approaching the threshold where something new can emerge. You can feel the anticipation building in the cosmic medium, like the moment before sunrise when the eastern horizon begins to show the first hint of dawn. The scattered particles of matter, mostly hydrogen and helium nuclei, drift peacefully through the radiant plasma, waiting for the moment when they can begin to combine into atoms. And then, after 380,000 years of patient waiting, the cosmic temperature drops to about 3,000 degrees Kelvin, still hot enough to melt copper, but cool enough for something revolutionary to occur. The electrons that have been dancing freely through space begin to slow down, their kinetic energy reducing to the point where they can be captured by the nuclei that have been waiting so patiently for this cosmic courtship. This is the moment of first bonding, when hydrogen nuclei and electrons embrace for the first time, forming the simplest atoms in the universe. The process is as gentle as snowflakes forming in winter air, as natural as lovers finding each other across a crowded room. One by one throughout the entire visible universe, atoms begin to assemble themselves from their component parts, like cosmic Lego blocks clicking softly into place. As these first atoms form, something magical happens to the light that has been scattered continuously throughout the cosmos. Suddenly, for the first time in the universe's history, photons can travel freely through space without constantly colliding with free electrons. The cosmic fog lifts, and the universe becomes transparent to its own light. This liberation of light is so significant that we can still detect it today as the cosmic microwave background radiation, the afterglow of creation itself, cooled by billions of years of expansion, but still present as a gentle warmth that fills all of space. Picture this moment of cosmic transparency, like the clearing of morning mist from a lake, revealing for the first time the full extent of the waters and the far shores that were always there, but never before visible. The universe sees itself clearly for the first time, light streaming freely across the growing distances between matter that is beginning to clump together under the patient influence of gravity. The newly formed atoms, mostly hydrogen with some helium, begin their slow gravitational dance, drawing together in regions where matter is slightly denser than average. These density fluctuations, imprinted during the first moments of inflation, serve as the seeds around which all future structure will grow. Like gentle whirlpools forming in a slowly moving stream, matter begins to collect in patterns that will eventually become the scaffolding for galaxies, stars, and planets. As you float through this era of first transparency, you can feel the profound shift that has occurred. The universe has learned to see, learned to allow light to travel freely across vast distances, learned to organize matter into increasingly complex patterns. The stage is now set for the next great movement in the cosmic symphony, the formation of the first stars that will light up the darkness and begin the patient alchemy of creating heavier elements. The background temperature of space continues to cool, now approaching the frigid cold that characterizes the modern universe. But within the slowly condensing clouds of hydrogen and helium, gravitational compression is beginning to generate heat, preparing for the moment when nuclear fusion will ignite, and the first stars will begin to shine. The universe is pregnant with possibilities, dark matter providing the invisible scaffolding around which ordinary matter will organize itself into the first cosmic structures. And as these elements gather, as gravity weaves its patient patterns through the expanding cosmos, you can sense the approaching dawn of the next great era. Rivers of gas begin to flow along invisible highways of dark matter, converging toward the places where the first galaxies will eventually bloom like flowers in a cosmic garden. The universe has learned to be transparent, learned to form atoms, and now it prepares to learn the art of making light in the darkness. Softly forming, softly glowing, softly continuing, the rhythm of creation establishes itself as the fundamental heartbeat of existence. What began as pure potential has become space and time and matter and energy, all dancing together in perfect harmony as the cosmos prepares for its next gentle transformation. And as these elements gather, rivers of stars begin to flow, shaping the first galaxies in the ever-expanding tapestry of cosmic becoming. Drift now through the cosmic dawn, floating peacefully in a universe that has learned transparency and atomic harmony. Around you, vast clouds of hydrogen and helium gas flow like gentle rivers through the darkness, following invisible currents carved by the patient hand of gravity. These are not violent torrents but slow, majestic streams that take millions of years to change course, carrying the seeds of all future light and life toward their cosmic destiny. In this era of patient gathering, roughly 100 to 200 million years after the Great Opening, the universe resembles a vast ocean at twilight, dark and peaceful, yet stirring with currents that hint at the dawn to come. The temperature of space has cooled to near absolute zero, but within the slowly contracting gas clouds, something warm is beginning to stir. Gravity, that most gentle of all forces, works with infinite patience to draw matter together, each atom attracting every other atom with the soft persistence of love itself. Feel yourself floating through one of these primordial clouds, a structure so vast that light takes thousands of years to cross from one side to the other. The gas around you is thinner than the best vacuum we can create on Earth, yet it extends for distances that dwarf our solar system. Within this tenuous medium, the dance of condensation begins as naturally as dew forming on morning grass. Tiny fluctuations in density, seeded during the first moments of creation, begin to grow and amplify under gravity's nurturing influence. The process unfolds with the patience of geological time. Regions slightly denser than their surroundings attract more matter, growing slowly stronger in their gravitational embrace. Like whirlpools forming in a gentle stream, these condensations begin to rotate slowly, their spin helping to channel inflowing gas into organized patterns. The universe is learning the art of structure, discovering how to weave matter into increasingly complex and beautiful forms. As you drift deeper into this cosmic choreography, you can feel the profound silence that still characterizes this era. There are no stars yet to sing with electromagnetic radiation, no nuclear fires to illuminate the darkness. The only light comes from the fading afterglow of creation itself, now stretched into invisible radio waves by the expansion of space. Yet beneath this apparent emptiness, the universe thrums with potential energy, like a vast instrument waiting for its first note to be played. The first galactic structures begin to emerge like mountains, rising slowly from the sea. These are not the elegant spiral galaxies we see today, but loose, irregular collections of gas clouds held together by the invisible scaffolding of dark matter. Think of them as cosmic nurseries, vast regions where the ingredients for star formation are being gently organized and prepared. They form along filaments of dark matter that crisscross the universe like a three-dimensional spiderweb, each intersection a potential birthplace for a new galaxy. Within these proto-galaxies, the density of gas gradually increases as millions of years pass like slow breaths. The clouds contract under their own weight, their centers growing warmer as gravitational potential energy converts to heat. This warming is as gentle as sunlight touching your face on a spring morning, yet it marks the beginning of one of the most beautiful processes in the cosmos, the transformation of cold gas into blazing stars. Picture now the moment when the first star begins to form. Somewhere in the heart of a condensing gas cloud, the process starts as a whisper, a slight increase in density that begins to attract surrounding material. Over hundreds of thousands of years, matter flows inward along graceful spiral patterns, adding mass to the growing stellar embryo. The temperature at the center rises slowly, degree by degree, as the weight of accumulating gas presses down with ever-increasing force. At 10 million degrees Kelvin, something miraculous occurs. The hydrogen nuclei that have been drifting peacefully through space for millions of years suddenly have enough energy to overcome their mutual repulsion and fuse together, releasing energy in the process. This is not a violent explosion, but a gentle ignition. Like the lighting of a cosmic candle, nuclear fusion begins, and the first star breathes light into the darkness of space. Feel the profound significance of this moment. For the first time since the universe became transparent, light begins to shine from within matter itself. This first star, probably a massive giant composed almost entirely of hydrogen and helium, glows with the blue-white radiance of nuclear fire. Its light streams outward at 300,000 kilometers per second, carrying the news of its birth to regions of space that have known only darkness since the cosmic background radiation faded into invisibility. But this pioneer star is not alone for long. The shock waves from its birth, gentle pressure waves traveling through the surrounding gas, trigger the formation of other stellar embryos. Like lanterns being lit one by one across a vast landscape, stars begin to appear throughout the gas cloud. Each new birth makes the next more likely, as the combined radiation and stellar winds of existing stars stir the cosmic medium and create new pockets of density where future suns can form. These first stars are different from our modern sun in beautiful and important ways. Composed almost entirely of the primordial elements, hydrogen and helium, they burn hot and bright, consuming their nuclear fuel with the enthusiasm of cosmic youth. Many are dozens of times more massive than our sun, shining with the luminosity of millions of present-day stars. They live fast and bright, exhausting their hydrogen fuel in just a few million years, the blink of an eye in cosmic time. As you float peacefully among these first stellar fires, notice how they begin to change the universe around them. Their intense radiation pushes against the surrounding gas, carving out bubbles of hot, thin plasma. Their stellar winds, streams of charged particles flowing from their surfaces, sculpt the medium around them like gentle artists working with cosmic clay. For the first time in the universe's history, the environment around stars becomes dynamic and structured, shaped by the interaction between matter and energy. The light from these pioneer stars travels outward in all directions, and wherever it encounters neutral hydrogen gas, it causes a gentle transformation. The high-energy photons ionize the hydrogen atoms, stripping away their electrons and returning the gas to the plasma state it knew in the early universe. This reionization spreads outward from each star like ripples on a cosmic pond, gradually transforming the entire medium of space from neutral gas back to an ionized plasma that can interact more readily with electromagnetic radiation. But perhaps the most important contribution of these first stars is yet to come. Deep in their cores, where temperatures reach hundreds of millions of degrees, nuclear fusion creates the first heavy elements the universe has ever known. Carbon forms through the delicate balance of 3 helium nuclei coming together in just the right way. Oxygen emerges from the fusion of carbon and helium. Silicon, iron, and dozens of other elements are forged in the stellar furnaces, each one adding a new note to the cosmic symphony of matter. When these massive first stars exhaust their hydrogen fuel, they begin a graceful process of transformation. Their cores contract while their outer layers expand, becoming red supergiants that glow with the warm light of stellar autumn. The nuclear reactions in their cores become increasingly complex, creating heavier and heavier elements in a process that resembles the patient work of a cosmic alchemist. Iron builds up in the core until the star can no longer support its own weight through nuclear fusion. And then comes the moment of ultimate generosity. The core collapses in less than a second, rebounding in a shockwave that travels outward through the star's layers. But this is not destruction. It is the most beautiful form of cosmic recycling. The shockwave disperses the star's outer layers into space, seeding the surrounding medium with all the heavy elements that were created during the star's lifetime. Carbon, oxygen, silicon, iron, and dozens of other elements flow outward like seeds scattered by a cosmic gardener. These stellar gifts enrich the interstellar medium, providing the raw materials for a new generation of stars, and eventually planets. The next stars that form will have a small but crucial admixture of heavy elements, allowing them to burn more efficiently and live longer lives. Some will be cool enough and stable enough to nurture planetary systems where these heavy elements can combine into the complex molecules that make life possible. As you witness this first great cycle of stellar birth and transformation, you can feel how the universe is learning the fundamental rhythm that will guide its future evolution: condensation and ignition, fusion and enrichment, transformation and dispersal, followed by new condensation, enriched by the gifts of previous generations. This is the heartbeat of cosmic evolution, the patient process by which simple beginnings give rise to ever-increasing complexity and beauty. The early galaxies begin to take on more definite shapes as successive generations of stars form and enrich the interstellar medium. Rotation and magnetic fields help organize the gas into the familiar spiral patterns we see in modern galaxies. The interplay between star formation and stellar feedback, the energy and matter returned to space by dying stars, regulates the process, ensuring that galaxy formation proceeds at a sustainable pace over billions of years. Dark matter, that invisible scaffolding that comprises most of the universe's mass, continues to play its crucial role in this cosmic architecture. Its gravitational influence holds galaxies together and helps channel gas flows along vast filaments that connect one galaxy-forming region to another. Like the wooden framework that supports a growing building, dark matter provides the structure that allows ordinary matter to organize itself into the beautiful patterns we observe today. Feel how the universe has transformed during this era. What began as a smooth, uniform distribution of gas has become textured with the first galactic structures. What started as darkness illuminated only by the fading afterglow of creation has become punctuated by the brilliant points of stellar light. The cosmos has learned to make light from within itself, learned to create complexity from simplicity, learned to transform and enrich itself through the patient cycles of stellar evolution. The temperature of intergalactic space continues to cool as the universe expands, but now there are warm spots where stars and galaxies add their gentle heat to the cosmic environment. The medium between galaxies becomes structured, with tendrils of gas flowing along dark matter filaments and vast regions emptied by the expanding shock waves from stellar feedback. The universe is becoming heterogeneous, developing texture and structure that will provide the foundation for all future complexity. As this era of first light continues, you can sense the approaching next phase of cosmic evolution. The heavy elements created by dying stars are beginning to accumulate in the interstellar medium. The next generation of stars will form from gas that is slightly enriched with these cosmic gifts, allowing for new possibilities that were not available to the first stellar generation. The stage is being set for the formation of planetary systems where the heavy elements can condense into rocky worlds, gathering and settling, forming and flowing, balancing and breathing. The rhythm of cosmic evolution establishes itself as stars continue to form and evolve throughout the growing population of young galaxies. Each stellar birth adds light to the cosmos. Each stellar death adds complexity to the medium from which future stars will form. The universe has discovered the secret of sustainable growth through recycling and enrichment, a principle that will guide its evolution for billions of years to come. And beyond these growing galactic islands, other collections of gas and dark matter drift closer together, drawn by the patient persistence of gravity. The stage is set for even grander architectural projects as separate galaxies begin their slow gravitational dance toward eventual merger and union. The cosmos prepares for its next lesson in growth through harmonious joining, as individual galactic voices learn to blend into even richer cosmic harmonies. Float now through an epoch of cosmic maturation, where young galaxies drift like luminous islands through the vast ocean of space-time. The universe is roughly 1 to 3 billion years old, no longer an infant but entering its cosmic childhood, learning the beautiful art of connection and growth through harmonious joining. Around you, the first generation of stellar cities has established itself, each galaxy a collection of millions or billions of stars, glowing with the steady light of nuclear fusion and the occasional fireworks of stellar transformation. In this era of gentle gravitational choreography, you can witness one of the most beautiful processes in cosmic evolution, the slow, graceful dance of galaxies drawing together under the patient influence of their mutual attraction. These are not violent collisions but tender embraces that unfold over hundreds of millions of years, each step in the dance as deliberate and natural as the changing of seasons or the turning of tides. Picture two spiral galaxies approaching each other across the cosmic deep, their initial separation measured in millions of light-years. From your perspective, floating peacefully between them, they appear as distant glowing pinwheels, each one rotating slowly around its central hub with the stately rhythm of a cosmic ballet. Their approach is so gradual that if you were to observe from the surface of a planet within either galaxy, you would see no change from one generation to the next, no indication of the grand cosmic dance that is slowly bringing these stellar communities together. The invisible hand that guides this celestial courtship is gravity, working across vast distances with the patience of geological time. Each galaxy's dark matter halo extends far beyond its visible stars, creating a sphere of influence that can reach halfway to its nearest galactic neighbor. As these invisible halos begin to overlap, the gravitational attraction between the galaxies increases, slowly accelerating their approach, like dancers gradually quickening their pace as they move closer together. As you drift closer to observe this cosmic minuet, notice how the galaxies begin to respond to each other's presence long before their stars come anywhere near collision. Tidal forces, the same gentle influences that raise ocean waves on Earth, begin to stretch and distort the outer regions of each galaxy. Streams of stars are drawn out like cosmic ribbons, creating graceful tails and bridges that connect the two systems in an embrace of starlight. The process unfolds in movements, like a symphony written across cosmic time. In the first movement, lasting hundreds of millions of years, the galaxies perform their initial approach, their gravitational fields beginning to interpenetrate and influence each other's structure. Stars in the outer regions of each galaxy feel the pull of their approaching neighbor and begin to stream outward, creating the first tentative connections between the two systems. During the second movement, the galaxies make their first close passage, sweeping past each other in a graceful arc that takes them apart again before bringing them back together. This cosmic pas de deux triggers spectacular displays of star formation as gas clouds within each galaxy are compressed by tidal forces, igniting new stellar nurseries throughout both systems. The night sky within either galaxy would blaze with the blue-white light of young, massive stars, while nebulae glow with the soft radiance of hydrogen excited by stellar radiation. Feel the profound beauty of this process, as streams of stars flow between the galaxies, like luminous rivers connecting two cosmic continents. These stellar streams are not chaotic sprays, but organized flows that follow precise gravitational trajectories, each star maintaining its individual course while participating in the greater pattern of galactic interaction. Some stars are flung far out into intergalactic space, becoming cosmic hermits that will spend eternity traveling between the galaxy clusters. Others are drawn inward toward the centers of the merging systems, where they will contribute to the formation of new galactic nuclei. The third movement begins as the galaxies, having completed their first dance and moved apart, are drawn back together by their mutual gravitational attraction. This second approach is more intimate than the first, their orbital energy having been dissipated through tidal interactions and the friction of passing through each other's dark matter halos. The dance tightens, the tempo increases, and the structural changes become more dramatic as each galaxy loses its original form and begins to merge into a new unified system. Throughout this process, the stars themselves remain largely unaffected by direct collisions. The distances between stars within a galaxy are so vast that even when two galaxies merge completely, the probability of any two stars actually colliding is vanishingly small. Instead, each star follows a new trajectory determined by the changing gravitational field of the merged system, like dancers learning new steps as the music of the cosmos shifts to a different rhythm. The gas within the merging galaxies tells a different story. Unlike the stars, which can pass by each other without interaction, gas clouds do collide and merge, creating shock waves that compress the medium and trigger spectacular bursts of star formation. These starburst events can increase the rate of stellar birth by factors of 10 or even 100, transforming spiral galaxies with modest star formation rates into blazing stellar factories that consume their gas reserves in a cosmic rush of creativity. As you witness this transformation, notice how the merger process creates entirely new types of galactic structures. The ordered spiral patterns that characterize the original galaxies are disrupted and eventually destroyed, their elegant arms unwound by tidal forces and scattered into more random distributions. In their place, elliptical galaxies begin to form, smooth, round or oval systems, where stars orbit in all directions rather than following the organized circular paths typical of spiral galaxies. The supermassive black holes that reside at the centers of both galaxies also participate in this cosmic dance. These gravitational giants, each containing millions or billions of times the mass of our Sun, slowly spiral toward each other as the galaxies merge, their approach generating gravitational waves that ripple through the fabric of space-time itself. When they finally merge, the resulting gravitational wave burst is so powerful it can be detected by sensitive instruments across billions of light-years of space. But this process of galactic merger is not limited to pairs of galaxies. Throughout the universe, entire groups and clusters of galaxies are slowly coming together, drawn by the same gravitational forces that unite individual galactic systems. You can observe galaxy clusters forming like cosmic cities, with dozens or even hundreds of individual galaxies settling into gravitational neighborhoods held together by vast halos of dark matter. The intracluster medium, the thin gas that fills the space between galaxies within these clusters, becomes heated to millions of degrees by the gravitational energy released during the formation process. This hot gas glows in X-rays, creating a diffuse radiance that outlines the dark matter scaffolding of the cluster and reveals the large-scale structure of the cosmic web that underlies all galactic organization. As you drift through one of these forming galaxy clusters, feel the profound sense of cosmic community that emerges from these gravitational gatherings. Individual galaxies, which began as isolated islands of stars in the cosmic ocean, gradually discover their neighbors and begin to participate in larger social structures. The universe is learning the art of organization on ever larger scales, from individual stars to galaxies to clusters to superclusters that span hundreds of millions of light-years. The heavy elements created by successive generations of stars continue to enrich the interstellar and intergalactic medium during this era of galactic interactions. Each starburst triggered by galaxy mergers creates a new population of massive stars that live brief, brilliant lives before dispersing their nucleosynthetic products into the cosmic environment. The metallicity, the abundance of elements heavier than hydrogen and helium, gradually increases throughout the universe, providing the raw materials necessary for the formation of terrestrial planets and the complex chemistry of life. Notice how the process of galaxy interaction and merger actually accelerates the pace of cosmic evolution. The shock waves generated by colliding gas clouds, the gravitational stirring of stellar populations, and the enhanced star formation rates all contribute to a universe that is changing more rapidly than it did during the era of isolated galactic evolution. The cosmos is discovering that growth through connection and interaction can be more dynamic and creative than growth in isolation. This principle of enhanced creativity through interaction extends beyond the scale of galaxies to influence the evolution of stars and planetary systems as well. The dense environments within galaxy clusters, the shock waves from galaxy mergers, and the enhanced heavy element abundances all create new possibilities for stellar and planetary formation that were not available in the early isolated universe. The dark energy that drives the expansion of space continues its patient work during this era, ensuring that the universe as a whole continues to grow even as local regions become more densely packed through gravitational collapse. This creates a beautiful tension between the universal tendency toward expansion and the local tendency toward condensation and structure formation, a cosmic balance that allows both processes to proceed simultaneously without interfering with each other. As you observe this epoch of cosmic connection and growth, you can sense the approaching transition to an even more mature phase of universal evolution. The most massive galaxy clusters are beginning to establish themselves as permanent features of the cosmic landscape. The rate of galaxy mergers is approaching its peak, with the most dramatic interactions creating the massive elliptical galaxies that will dominate the centers of galaxy clusters for billions of years to come. The interplay between dark matter, ordinary matter, and dark energy is reaching a kind of dynamic equilibrium that will characterize the universe for the next several billion years. Structure formation continues, but at a more measured pace, as the expansion of space begins to win the competition with gravitational collapse on the largest scales. The cosmic web of dark matter filaments and voids is approaching its mature configuration, providing a stable framework for future galactic evolution. Feel the profound sense of anticipation that characterizes this moment in cosmic history. The universe has learned to create increasingly complex structures through the patient process of gravitational assembly. It has discovered how to recycle and enrich matter through stellar evolution and galactic interactions. The stage is now set for the next great flowering of cosmic creativity, the formation of the most complex and beautiful galactic structures the universe will ever produce. Joining and blending, flowing and weaving, balancing and breathing, the rhythm of cosmic evolution continues as individual galactic voices learn to harmonize in the growing chorus of galaxy clusters and superclusters. The universe approaches the peak of its structural creativity, preparing to enter its golden age of maximum galactic diversity and stellar productivity. With each dance complete, the cosmos blossoms into its greatest period of light and complexity, ready to create the most magnificent stellar gardens it will ever know. Drift now into the most magnificent epoch of cosmic history, the golden age of the universe, when creation reaches its peak of diversity, beauty, and generative power. This is the cosmic spring, roughly 3 to 6 billion years after the Great Opening, when the universe achieves its most perfect balance between the forces of expansion and the patient creativity of gravitational collapse. Around you flows a cosmos in full bloom, where galaxies shine with the radiance of billions of stars, where stellar nurseries birth new suns at rates that will never again be matched, and where the heavy elements necessary for rocky planets and complex chemistry have accumulated to levels that open infinite possibilities for future complexity. Feel yourself floating through a universe that has learned to optimize beauty and productivity in perfect harmony. The great galaxy clusters have stabilized into magnificent cosmic cities, each one a collection of hundreds or thousands of individual galaxies, arranged in patterns that reflect the underlying dark matter architecture. These clusters shine with the combined light of trillions of stars, their glow so intense it can be detected across billions of light-years of space, serving as lighthouses that illuminate the cosmic web itself. The Milky Way galaxy, destined to become our cosmic home, participates fully in this golden age of stellar creativity. Picture it as it appears during this epoch, a magnificent spiral galaxy, with arms that sweep gracefully through space like frozen music, each arm outlined by brilliant blue-white stars, and the rose-colored glow of stellar nurseries, where new suns are born in continuous abundance. The galaxy rotates with stately grace, completing one full turn every 200 million years, its spiral pattern maintained by density waves that organize star formation into these beautiful curved structures. Within the galaxy's spiral arms, massive molecular clouds drift like cosmic mountains, some containing enough material to birth thousands of new stars. These stellar nurseries are the most active and creative regions in the galaxy, where gravity works its patient magic to transform cold gas into blazing nuclear furnaces. The process of star formation has been refined through billions of years of cosmic evolution, reaching a peak efficiency that creates stars of every possible mass and type, from tiny red dwarfs that will burn steadily for trillions of years to massive blue giants that live fast and bright before gifting their nuclear products back to the cosmic community. As you drift through one of these stellar birthplaces, Notice how the process has become beautifully organized and efficient. Shock waves from the deaths of previous stellar generations compress the molecular clouds, triggering new rounds of star formation in a process that sustains itself across cosmic time. The heavy elements dispersed by dying stars provide the raw materials for planetary systems, while the energy released by young stars regulates the rate of future star birth, preventing the galaxy from consuming its gas reserves too quickly. The stars that form during this golden age are fundamentally different from the first stellar generation that lit up the early universe. Enriched with heavy elements from billions of years of stellar nucleosynthesis, they burn more efficiently and live longer lives. Many are similar to our own Sun, moderate mass stars with stable nuclear fusion that will shine steadily for billions of years, providing the consistent energy sources that complex processes require. Around these stable stars, planetary systems begin to form from the accumulated dust and debris of stellar evolution. Witness the birth of a planetary system during this epoch of cosmic creativity. Within the swirling disk of gas and dust that surrounds a newly formed star, microscopic grains begin to stick together through electrostatic forces and gentle collisions. These tiny aggregations grow slowly into pebbles, then boulders, then planetimals, small bodies that serve as the building blocks for full-sized planets. The process unfolds over millions of years with the patience of geological time, each collision and accretion event adding mass and complexity to the growing worlds. The inner regions of the planetary system, warmed by the central star's radiation, become the realm of rocky planets where heavy elements can condense into solid form. Here, iron and silicon and magnesium organize themselves into the mineral structures that will form planetary cores and crusts. Water, carried inward by comets and asteroids from the colder outer regions, begins to accumulate on those worlds where temperature and atmospheric conditions allow it to exist in liquid form. On some of these rocky worlds, a miracle begins to unfold that represents the universe's greatest achievement in complexity and creativity. The heavy elements that were forged in stellar cores and dispersed by dying stars begin to organize themselves into increasingly complex molecules. Carbon, that most versatile of elements, forms the backbone of elaborate molecular structures that can store information, catalyze reactions, and even replicate themselves with remarkable fidelity. Feel the profound significance of this moment when chemistry becomes complex enough to begin the transition toward biology. The universe, which began as pure energy and learned to become matter, and then learned to organize matter into stars and galaxies, now discovers how to arrange atoms into molecules that can process information and respond to their environment. This is the emergence of life, not as a violation of cosmic law, but as the natural flowering of the universe's increasing ability to create complex, organized structures. The first living systems are profoundly simple compared to modern organisms, yet they represent a revolutionary new form of cosmic creativity. These early self-replicating molecules, floating in the warm seas of young planets, have learned to use environmental energy to maintain and reproduce their organized structure. They are the universe becoming aware of itself at the molecular level, matter learning to respond adaptively to information and change. As these early biological processes evolve and complexify, they begin to modify the environments of their home planets in profound ways. Photosynthetic organisms learn to capture the energy of starlight and use it to transform atmospheric gases, releasing oxygen as a byproduct of their metabolic processes. This biological terraforming creates new environmental niches that evolution can explore, leading to an explosion of biological diversity and complexity. On countless worlds throughout the galaxy, this process of biological evolution unfolds along similar principles, but with endless variations in detail. Each planet's unique combination of stellar radiation, atmospheric composition, geological activity, and chemical environment creates a different evolutionary laboratory where life explores new solutions to the challenges of survival and reproduction. The universe becomes a vast experiment in biological creativity, with each inhabited world contributing its own insights to the cosmic exploration of what life can become. The Golden Age is characterized not just by biological evolution on individual planets, but by the optimization of galactic ecology on the largest scales. Star formation rates reach their peak during this epoch, creating the maximum possible number of stable, long-lived stars that can nurture planetary systems for billions of years. The abundance of heavy elements reaches optimal levels for rocky planet formation, while gas giant planets help protect inner worlds from asteroid impacts that could disrupt the slow process of biological evolution. Galaxy interactions during this epoch often trigger enhanced star formation without completely disrupting the delicate environments where life is beginning to flourish. The gravitational dances between galaxies create new stellar nurseries and redistribute heavy elements throughout galactic systems, increasing the number of worlds where biological processes can take root and diversify. The cosmos achieves a beautiful balance between stability and creativity, change and continuity. The supermassive black holes at the centers of galaxies play increasingly important roles during this epoch, regulating star formation through their periodic outbursts of energy. These cosmic engines, fed by the slow accretion of gas and occasional stellar meals, release jets of high-energy particles that can travel thousands of light-years from their galactic centers. Rather than simply destroying, these energetic outflows help regulate the pace of star formation, preventing galaxies from consuming their gas reserves too quickly and ensuring that stellar birth can continue for billions of years. As you float through this golden age cosmos, notice how every scale of organization has achieved a kind of optimal functionality. Individual stars burn steadily and efficiently, transforming hydrogen into heavier elements at sustainable rates. Galaxies maintain their spiral structure through the balance of rotation, gravity, and stellar feedback. Galaxy clusters achieve gravitational equilibrium that allows them to retain their hot gas while continuing to accrete new members from the surrounding cosmic web. The dark energy that drives cosmic expansion continues its patient work, ensuring that the universe as a whole continues to grow even as local regions reach peak complexity. This creates a cosmic environment where both expansion and structure formation can proceed simultaneously, allowing the universe to maximize both its diversity and its creative potential. Space provides the canvas while gravity provides the brush, and together they paint the most magnificent cosmic artwork the universe will ever create. During this epoch, the first intelligent civilizations may begin to emerge on worlds where biological evolution has had billions of years to explore the possibilities of neural complexity and social organization. These early instances of cosmic consciousness represent the universe's first attempts to understand itself through the medium of evolved intelligence. They are like the first glimmers of cosmic dawn, individual minds beginning to contemplate their place in the vast symphony of existence. The communication between these scattered islands of consciousness, if it occurs at all, unfolds at the leisurely pace of light traveling between stars. Radio waves and other electromagnetic signals carry the first intentional messages across interstellar space, creating tenuous webs of information exchange that span light years. The universe begins to develop a primitive nervous system, with individual minds serving as neurons and electromagnetic radiation serving as the synapses that connect them across cosmic distances. Technology, where it emerges, represents another form of cosmic creativity, intelligence learning to reshape matter and energy according to conscious intention. The first technological civilizations begin to harness stellar energy, to travel between worlds within their planetary systems, and to contemplate the engineering projects that could reshape entire galactic regions according to intelligent design. The universe discovers that consciousness plus technology equals a new form of creative power that can work alongside natural processes to increase complexity and beauty. The Golden Age represents the peak of what we might call natural cosmic evolution, the epoch when the universe achieves its maximum creative potential through the interplay of gravity, nuclear fusion, chemistry, and biology operating according to their inherent principles. It is the cosmic equivalent of a mature ecosystem where every niche has been filled and every possible form of organization has been explored and optimized. Yet even during this period of peak flourishing, the seeds of future change are already present. The expansion of space continues, gradually diluting the density of matter and reducing the rate of galaxy interactions. The most massive stars consume their nuclear fuel and transform into neutron stars and black holes, removing some of the galaxy's brightest lights, while adding to its population of gravitational anomalies. The universe begins its slow, graceful transition from the exuberant creativity of cosmic youth toward the more measured pace of galactic middle age. Feel the bittersweet beauty of this realization as you float through the Golden Age cosmos. This is as good as it gets, the peak moment when the universe achieves its most perfect balance of stability and creativity, structure and change, simplicity and complexity. Every galaxy shines with optimal brightness. Every planetary system explores new possibilities for complexity. Every biological experiment adds to the cosmic store of information and adaptation. The music of the spheres reaches its crescendo during this epoch, with gravitational waves from merging black holes, electromagnetic radiation from active galactic nuclei, and the subtle quantum fluctuations that drive stellar nucleosynthesis, all contributing to a cosmic symphony of unprecedented richness and complexity. The universe sings with all its voices, from the deep bass notes of dark matter interactions to the high, bright melodies of stellar formation and the complex harmonies of biological evolution. Blossoming, flowering, awakening, in gentle rhythm, the universe achieves its moment of maximum beauty and creative power, a cosmic spring that will be remembered and celebrated, even as autumn approaches and winter threatens in the distant future. The tree of cosmic evolution has found its perfect flowering, and for this golden moment, all possibilities seem within reach, all forms of beauty achievable, all expressions of consciousness ready to emerge from the fertile soil of an optimally organized cosmos. And yet, even in this moment of perfect flourishing, time continues its patient flow forward, carrying the universe toward new challenges and new forms of maturity. The Golden Age prepares to give way to a different kind of beauty, the serene wisdom of cosmic maturation, where growth becomes more measured, change is more subtle, and the universe learns new forms of grace appropriate to its advancing age. Drift now into the era of cosmic maturation, where the universe, having achieved its golden age of peak creativity, begins the graceful transition toward a more measured and contemplative phase of existence. This is cosmic middle age, roughly 6 to 10 billion years after the Great Opening, when the exuberant star formation of galactic youth gradually gives way to more sustainable rhythms of stellar birth and death. Like a river that has found its proper course, and now flows with steady purpose toward the sea, the universe settles into patterns that will characterize its mature phase for billions of years to come. The great galaxy clusters have achieved gravitational equilibrium, their hundreds or thousands of member galaxies arranged in stable configurations that reflect the underlying architecture of dark matter. These cosmic cities shine with a softer, more amber light than during their youth, as the brilliant blue-white stars of earlier epochs evolve into cooler, longer-lived phases of stellar evolution. The universe is learning the art of sustainability, discovering how to maintain its beauty and complexity while using resources more efficiently. Feel yourself floating through a cosmos that has gained wisdom through experience. The rate of star formation has declined from its golden age peak, but this is not decay, it is optimization. Galaxies have learned to regulate their stellar birth rates to ensure that they can continue creating new stars for tens of billions of years, rather than exhausting their gas reserves in a brief burst of creativity. The universe has discovered the principle of sustainable development, balancing present productivity with future potential. The Milky Way during this epoch exemplifies this cosmic maturation. Its spiral arms still sweep majestically through space, but they are now outlined more by the steady glow of mature stars than by the brilliant fireworks of massive stellar nurseries. The galaxy's stellar population has become increasingly dominated by stars like our Sun, moderate mass, hydrogen-burning stars that will shine steadily for billions of years, providing the stable energy sources that complex biological processes require to evolve and flourish. Within the galaxy's disk, a new type of cosmic ecology has emerged. The interstellar medium has become enriched with heavy elements to the point where terrestrial planet formation is not only possible but inevitable around most newly formed stars. These rocky worlds, composed of iron and silicon and carbon and other stellar gifts, provide stable platforms where chemistry can explore its most complex possibilities over geological timescales measured in billions of years. On countless worlds throughout the mature galaxy, biological evolution has had sufficient time to explore sophisticated solutions to the challenges of survival and reproduction. Multicellular organisms have emerged on many planets, their cells organized into increasingly complex societies that can process information, respond to environmental changes, and even modify their surroundings to create more favorable conditions for life. The universe is learning biology at the level of tissues and organs, discovering how individual cells can cooperate to create emergent properties that transcend their individual capabilities. Some of these biological experiments have achieved neural complexity sufficient to support consciousness, the universe's most remarkable achievement in self-organization. On worlds where evolution has had billions of years to explore the possibilities of information processing, nervous systems have emerged that can not only respond to immediate environmental stimuli, but can also model possible futures, remember complex past experiences, and even contemplate abstract concepts like beauty, truth, and meaning. These early consciousnesses represent the universe becoming aware of itself in a fundamentally new way. Through evolved eyes, the cosmos begins to see its own beauty. Through evolved minds, it begins to understand its own history and contemplate its own future. Through evolved hearts, it begins to appreciate the profound meaning embedded in its long journey from simplicity to complexity, from unconscious matter to conscious spirit capable of wonder and love. The emergence of intelligence on scattered worlds throughout the galaxy creates the first tentative networks of cosmic communication. Radio telescopes scan the skies, searching for signals from other minds across the vast distances of interstellar space. Mathematical messages are broadcast toward nearby star systems, carrying the hope that someone, somewhere, might be listening and ready to respond. The universe experiments with the possibility of mind speaking to mind across the cosmic distances that separate one world from another. Technology, where it emerges from the marriage of intelligence and manipulative capability, represents a new form of cosmic creativity. Conscious beings learn to reshape matter and energy according to intentional design, creating tools and machines that extend their capabilities far beyond what biology alone could achieve. The first technological civilizations begin to harness the full energy output of their parent stars, to travel between the worlds of their planetary systems, and to contemplate engineering projects on galactic scales. Yet this era of maturation is also characterized by a growing awareness of cosmic limitations and the need for wisdom in the application of creative power. The expansion of space continues, gradually reducing the density of matter and making it more difficult for gravity to bring together the materials needed for new star formation. The universe begins to confront the reality that its resources, while vast, are not infinite, and that long-term sustainability requires careful stewardship of available energy and matter. The most massive stars, those brilliant giants that illuminated the Golden Age with their intense radiation, continue their rapid evolution toward explosive transformation. As they exhaust their nuclear fuel and undergo the graceful process of stellar death, they enrich the interstellar medium with heavy elements while removing some of the galaxy's brightest lights. The stellar population gradually shifts towards smaller, longer-lived stars that burn their fuel more efficiently and can maintain steady nuclear fusion for tens of billions of years. Galaxy interactions during this epoch become less frequent and less violent as the expansion of space increases the average distances between galactic systems. When mergers do occur, they unfold with even greater stateliness than during earlier epochs, their gravitational dances extending over hundreds of millions of years. These interactions continue to trigger bursts of star formation and the creation of new stellar populations, but at a more measured pace that reflects the universe's growing maturity. The supermassive black holes at galactic centers play increasingly important roles in regulating the pace of cosmic evolution. Having grown through billions of years of accretion and galactic mergers, these gravitational giants now contain billions of times the mass of typical stars. Their periodic feeding episodes, when gas falls into their event horizons, release tremendous amounts of energy that can regulate star formation throughout their host galaxies, and even affect the evolution of entire galaxy clusters. Dark energy continues its patient work of driving cosmic expansion, but its effects become more noticeable during this epoch, as matter density decreases, and the repulsive influence of vacuum energy begins to dominate over the attractive influence of gravity on the largest scales. The cosmic web of dark matter filaments and voids approaches its mature configuration, with galaxy clusters connected by tenuous bridges of matter and separated by increasingly empty regions where space expands more rapidly than matter can flow to fill it. As you drift through this era of cosmic maturation, notice how the universe has learned to optimize for longevity rather than intensity. The brilliant pyrotechnics of galactic youth give way to the steady glow of mature stellar populations. The rapid pace of structure formation slows to a more sustainable rhythm. The cosmos discovers that true beauty lies not in maximum brightness, but in optimal balance, the ability to maintain complexity and creativity over the longest possible timescales. Biological evolution on countless worlds explores the possibilities of consciousness and intelligence, creating an ever-increasing diversity of ways that the universe can become aware of itself. Some worlds develop individual consciousness to high degrees of sophistication. Others explore collective intelligence, where groups of organisms function as unified cognitive systems. Still others experiment with hybrid forms of biological and technological consciousness, creating new types of minds that transcend the limitations of purely biological neural networks. The mature universe becomes a vast laboratory for exploring the possibilities of mind and meaning. Each inhabited world contributes its own insights to the cosmic investigation of what consciousness can become, and what purposes conscious beings might pursue. The universe begins to grapple with questions that transcend mere survival and reproduction. What is the purpose of consciousness? What kinds of lives are worth living? How should intelligent beings relate to each other and to the cosmos that gave them birth? Communication networks between civilizations, where they exist, operate at the patient pace of light traveling between stars. Ideas and discoveries propagate through interstellar space like ripples spreading across a cosmic pond, each world adding its own contributions to the growing store of cosmic knowledge and wisdom. The universe develops a primitive form of cultural evolution, where insights discovered on one world can influence the development of consciousness and civilization on distant worlds. Art and music and literature begin to emerge wherever consciousness achieves sufficient sophistication to appreciate beauty for its own sake, rather than merely as a signal of biological fitness. The universe learns to create meaning and beauty intentionally, through the conscious choices of evolved minds, rather than only through the unconscious processes of natural selection and physical law. Conscious beings become partners with natural processes in the ongoing creation of cosmic beauty and complexity. The era of maturation is also characterized by the first serious attempts at cosmic engineering, conscious efforts to reshape physical reality according to intelligent design. Some civilizations begin to modify their home planets to optimize conditions for biological flourishing. Others undertake projects to harness stellar energy more efficiently, or to protect their worlds from cosmic hazards like asteroid impacts or stellar radiation. The most ambitious begin to contemplate truly galactic engineering projects that could reshape entire stellar systems according to conscious intention. Yet with great power comes the need for great wisdom, and the mature universe becomes a testing ground for whether consciousness can learn to use its capabilities responsibly. Some civilizations may exhaust their resources through unsustainable growth or destroy themselves through conflicts over competing visions of how reality should be shaped. Others learn to achieve balance between their desires and their capabilities, discovering how to create sustainable civilizations that can flourish for millions or even billions of years. The cosmic background radiation, that ancient echo of creation, continues to cool as space expands, its temperature now approaching the frigid cold that will characterize the universe's far future. Yet scattered throughout the cosmos, the fires of stellar nuclear fusion continue to provide warmth and energy for the countless experiments in complexity and consciousness that represent the universe's ongoing creative work. Gravitational waves from merging black holes and neutron stars ripple through the fabric of space-time, carrying information about cosmic events across billions of light-years. These gravitational messages may represent the universe's most fundamental form of communication, vibrations in the very structure of space that connect every region of the cosmos, in a network of shared information about mass, energy, and motion. As this epoch of graceful maturation continues, you can sense the approaching transition to an even more contemplative phase of cosmic evolution. The universe has learned sustainability, learned wisdom, learned to balance creativity with conservation. It has discovered consciousness and begun to explore the implications of mind emerging from matter. The stage is set for the next great challenge, learning how to maintain meaning and purpose, even as the physical resources available for cosmic creativity gradually diminish. Breathing in, breathing out, glowing softly, fading gently, the rhythm of cosmic respiration establishes itself as the universe learns to pace its creative work for maximum longevity. The cosmos has achieved a mature wisdom that values sustainability over intensity, depth over breadth, quality over quantity, and yet, even in this peaceful maturation, new challenges are approaching that will test whether the universe's hard-won wisdom is sufficient to guide it through the trials that await in its cosmic future. Float gently now through an epoch where the universe encounters its first profound challenges to the sustainability it has worked so patiently to achieve. This is not a time of cosmic crisis, but rather a period of gentle adversity that teaches the cosmos new forms of resilience and adaptation. Like a gardener who must learn to tend plants through both favorable seasons and times of drought, the universe discovers how to maintain its essential beauty and creativity, even as external conditions begin to shift in ways that will test its accumulated wisdom. The expansion of space, that patient force that has been stretching the fabric of reality since the Great Opening, now begins to assert itself more noticeably in the cosmic balance of forces. Dark energy, the mysterious influence that drives this expansion, gradually overcomes the gravitational attraction between distant galactic structures. The cosmic web of galaxy clusters and superclusters, which has been the stable framework for cosmic organization during the era of maturation, begins to experience a gentle stretching that will eventually separate its components beyond the reach of gravitational reunion. This is not violent disruption but cosmic yoga, the universe learning to stretch and adapt to new geometries while maintaining its essential structural integrity. Individual galaxy clusters remain gravitationally bound, their member galaxies continuing to orbit each other in the same stately patterns they have followed for billions of years. But the distances between separate clusters gradually increase, like islands slowly drifting apart on an expanding ocean, each one maintaining its local ecosystem while becoming increasingly isolated from its neighbors. Within individual galaxies, the challenges are more subtle but equally profound. The rate of star formation continues its gradual decline, as gas reservoirs are consumed by stellar birth and dispersed by the energetic feedback from dying stars. Galaxies must learn to manage their resources more carefully, balancing the creation of new stars against the need to maintain sufficient raw materials for future stellar generations. The universe discovers the principles of resource management on a cosmic scale. The most massive stars, those brilliant giants that have provided much of the heavy element enrichment for galactic chemical evolution, continue their rapid evolution toward spectacular transformation. When these stellar giants exhaust their nuclear fuel, they undergo a process of graceful core collapse followed by gentle envelope dispersal, what we might call stellar recycling rather than stellar death. The core collapse creates neutron stars and black holes, while the dispersed envelopes seed the interstellar medium with the full periodic table of elements created through stellar nuclear synthesis. Picture the beauty of a supernova not as a violent explosion, but as a stellar breath exhaled across light years of space. The shock wave that travels outward from the collapsed core does not destroy but transforms, compressing nearby gas clouds and triggering new episodes of star formation. The heavy elements dispersed by this cosmic exhalation, carbon and oxygen and silicon and iron, drift through the galaxy like cosmic pollen, ready to be incorporated into the next generation of stars and planets. These stellar transformations create new forms of cosmic architecture. Neutron stars, with their incredibly strong magnetic fields and rapid rotation, become cosmic lighthouses that sweep beams of radio radiation across the galaxy. Black holes, those regions where gravity has become so strong that space-time itself folds back on itself, serve as gravitational focal points that help organize the orbits of surrounding stars and gas clouds. Rather than being destructive anomalies, these extreme objects become integral parts of galactic ecosystems. Some black holes grow through gradual accretion of surrounding material, developing into active galactic nuclei that release tremendous amounts of energy in the form of jets and radiation. These energetic outbursts, rather than simply destroying their surroundings, help regulate star formation throughout their host galaxies. Like controlled burns that prevent forest fires, these periodic episodes of galactic activity clear away excess gas and dust while triggering new star formation in compressed regions. The supermassive black holes at galactic centers undergo their own form of evolution during this epoch. Having grown through billions of years of accretion and galactic mergers, they now contain billions of times the mass of ordinary stars. Their gravitational influence extends throughout their host galaxies, affecting the orbits of stars and the flow of gas in ways that help maintain galactic stability even as external conditions continue to change. On worlds where consciousness has emerged, this epoch presents unique challenges and opportunities. Civilizations must learn to adapt to environments that are slowly changing as their parent stars evolve and their galaxies consume their available resources. The most successful develop technologies and social systems that can function sustainably over geological timescales, learning to work within cosmic constraints rather than attempting to overcome them through brute force. The gradual decline in star formation rates means that the universe is slowly becoming darker, as the brilliant blue-white stars that have provided much of the cosmic illumination exhaust their fuel and fade from view. But this is not the darkness of ending. It is the gentle dimming of a cosmic campfire as the evening grows late and the gathered community settles into more intimate conversations around the dying embers. Biological evolution on countless worlds faces the challenge of adapting to slowly changing stellar environments. As parent stars evolve from main sequence burning toward red giant phases, planetary climates must adjust to new patterns of stellar radiation. Some worlds experience warming as their stars expand and brighten. Others may cool as stellar evolution reduces energy output. Life learns to adapt to these changes through evolutionary innovation, and where intelligence has emerged through technological intervention. The cosmic background radiation continues its patient cooling, its temperature now approaching the frigid depths that will characterize the universe's far future. Yet this cooling is not empty coldness but pregnant silence. The the quiet that allows subtle phenomena like gravitational waves and quantum fluctuations to be detected and appreciated by sufficiently sensitive instruments developed by curious civilizations. Communication between civilizations becomes both more challenging and more precious during this epoch. As galaxies drift apart due to cosmic expansion, the distances that signals must travel to reach other galactic communities gradually increase. Yet the very scarcity of intergalactic communication may make each contact more meaningful, leading to more careful and profound exchanges of knowledge and wisdom between scattered islands of consciousness. Some civilizations may respond to these challenges by attempting ever larger engineering projects designed to secure resources and energy for the long-term future. Dyson spheres that capture the full energy output of stars, stellar lifting that extends stellar lifetimes by removing excess mass, and galactic engineering projects that optimize star formation rates all represent attempts to work with cosmic evolution rather than simply accepting its constraints. Yet perhaps the most profound challenge of this epoch is philosophical rather than physical. As the universe begins to confront the reality of finite resources and changing conditions, conscious beings must grapple with questions of meaning and purpose in a cosmos that will not remain static forever. How should intelligent life respond to the knowledge that the current epoch of abundant energy and easy resource access will not last indefinitely? Some civilizations may choose the path of acceptance, learning to find beauty and meaning within the constraints imposed by cosmic evolution. Others may pursue the path of transcendence, developing technologies that allow consciousness to exist in forms that are less dependent on the specific physical conditions of the current epoch. Still others may focus on preservation, creating repositories of knowledge and culture that can survive even dramatic changes in cosmic conditions. The dark matter that provides the invisible scaffolding for galactic organization continues to play its essential role, but even it faces challenges as cosmic expansion stretches the filaments that connect galaxy clusters. The cosmic web gradually loses its connectivity as dark energy overcomes gravitational attraction on the largest scales. Individual nodes of the web, galaxy clusters and superclusters, maintain their internal structure while becoming increasingly isolated from their neighbors. This cosmic isolation creates opportunities, as well as challenges. Galaxy clusters become more self-contained ecosystems, forced to rely primarily on their internal resources for continued evolution and development. This may lead to greater diversity in galactic evolution as different clusters explore different solutions to the challenges of maintaining complexity in an expanding universe. The emergence of gravitational wave astronomy during this epoch, whether through natural cosmic processes or the development of sensitive detectors by technological civilizations, opens new windows for observing and understanding cosmic evolution. The merger of black holes and neutron stars sends ripples through space-time that carry information about these extreme events across cosmic distances, creating a new form of cosmic communication that operates through the very fabric of space itself. As you drift through this epoch of gentle adversity, notice how the universe responds to challenges, not with desperation or panic, but with creativity and adaptation. Each limitation becomes an opportunity to explore new forms of organization and efficiency. Each constraint becomes an invitation to discover new sources of beauty and meaning. The cosmos demonstrates that true resilience comes not from avoiding all difficulties, but from learning to find grace and purpose even in the face of genuine challenges. The music of the spheres takes on new harmonies during this epoch, as the cosmic symphony adapts to changing conditions while maintaining its essential beauty. The deep bass notes of galactic rotation continue, but they are joined by new melodies created by the gravitational waves from merging compact objects and the electromagnetic songs of pulsars and active galactic nuclei. The universe learns to make music even as some of its traditional instruments begin to show the effects of cosmic aging. Stretching and strengthening, bending and flowing with gentle forces, the cosmos demonstrates the wisdom of flexibility in the face of change. Like a tree that learns to bend with the wind rather than breaking in rigid resistance, the universe adapts its structures and processes to work within new constraints while maintaining its essential character and purpose. And yet, even as these challenges test the universe's accumulated wisdom, new possibilities continue to emerge. The growing population of neutron stars and black holes creates new opportunities for exotic physics and gravitational engineering. The accumulation of heavy elements in the interstellar medium opens new possibilities for complex chemistry and technological development. The development of consciousness to higher levels of sophistication creates new forms of cosmic creativity that can supplement and eventually transcend the limitations of purely physical processes. As this epoch of gentle adversity continues to unfold, you can sense the approaching transition to an era of even greater challenges and opportunities. The universe prepares to confront its destiny in the far future, when the current epoch of abundant stars and active galaxies will give way to new forms of cosmic organization. But the lessons learned during this time of testing, the importance of adaptation, the value of efficiency, the beauty of resilience, will serve as a foundation for whatever cosmic adventures lie ahead in the continuing story of universal evolution. And ahead waits the slowest of dances, a meeting with cosmic destiny that will test everything the universe has learned about creativity, sustainability, and the cultivation of meaning in the face of ultimate challenges. The cosmos prepares for its greatest transformation yet, confident in the wisdom it has accumulated through billions of years of patient learning and adaptation. Drift forward now through the flowing river of time, approaching one of the most magnificent cosmic events in our galaxy's future, the gentle ballet that will unite the Milky Way with its nearest major companion, the Andromeda Galaxy. This is not collision but courtship, a gravitational dance that has been choreographed by the patient laws of physics across billions of years of cosmic time. As you float peacefully through the present moment toward this destined encounter, roughly 4 billion years in our future, feel how this approaching union represents not an ending but a transformation, a marriage of two stellar communities that will create something more beautiful than either could achieve alone. Picture the current relationship between these two galactic partners, separated by 2.5 million light-years of space, but already bound together by the invisible threads of gravitational attraction. The Andromeda Galaxy, slightly larger than our own Milky Way, approaches at a leisurely pace of about 250,000 miles per hour, a speed that seems rapid by terrestrial standards, but represents the most stately of cosmic velocities when measured against the vast distances of intergalactic space. This approach has been underway for billions of years, each moment bringing the two systems incrementally closer to their destined union. As you drift through time toward this cosmic appointment, notice how the universe has been preparing for this event through eons of patient evolution. The heavy elements created by countless generations of stellar nucleosynthesis have enriched both galaxies with the raw materials necessary for rocky planet formation and complex chemistry. The supermassive black holes at each galactic center have grown to optimal sizes for regulating star formation during the coming merger. The stellar populations have matured to consist primarily of long-lived stable stars that can provide consistent energy sources even as their galactic environment undergoes dramatic transformation. The approach unfolds in movements, like a symphony written across geological time. In the first movement, spanning hundreds of millions of years, the two galaxies begin to feel each other's gravitational influence more strongly. Their outer halos of dark matter start to overlap, creating a shared gravitational field that begins to modify the orbits of stars in both systems. The most distant stellar streams and globular clusters start to respond to the gravitational pull of the approaching neighbor, beginning the slow redistribution of matter that will characterize the entire merger process. Feel yourself floating peacefully through this era of increasing gravitational intimacy, watching as tidal forces begin to sculpt both galaxies into new configurations. Long streams of stars are drawn out from the outer regions of each system, creating graceful bridges of starlight that span the diminishing distance between them. These stellar streams are not chaotic disruptions but organized flows that follow precise gravitational trajectories, each star maintaining its individual course while participating in the greater pattern of galactic transformation. During the second movement, the galaxies make their first close passage, sweeping past each other in a gravitational embrace that stretches over hundreds of millions of years. This cosmic pas de deux triggers spectacular episodes of star formation as gas clouds within both systems are compressed by tidal forces, igniting new stellar nurseries throughout the merging structure. The combined system blazes with the light of newborn stars, their blue-white radiance adding brilliance to a cosmic event that is already magnificent beyond description. The beauty of this process lies not in violence or destruction, but in the gentle transformation of two separate communities into a single, more complex system. Individual stars are rarely if ever involved in direct collisions. The distances between stars within galaxies are so vast that even during the merger, each stellar system continues to follow its own gravitational trajectory through the changing field created by the combined mass of both galaxies. As you witness this cosmic choreography, notice how the spiral structure that characterizes both galaxies begins to evolve into new forms. The elegant arms that have swept through space for billions of years are gradually unwound by tidal forces, their organized patterns giving way to more complex and ultimately more beautiful configurations. Stars that once followed circular orbits within galactic disks are scattered into elliptical patterns that fill three-dimensional space with greater completeness. The supermassive black holes at the centers of both galaxies begin their own slow dance toward union. These gravitational giants, each containing millions or billions of times the mass of an ordinary star, spiral toward each other over millions of years, their approach generating gravitational waves that ripple through the fabric of space-time itself. These waves carry away orbital energy, causing the black holes to spiral ever closer until they finally merge in a gravitational wave burst so powerful it can be detected across billions of light-years of space. The merger of these central black holes creates a new gravitational focus for the combined galactic system. The resulting supermassive black hole, fed by gas and stars disrupted during the merger process, may undergo periods of enhanced activity that regulate star formation throughout the new galaxy. Jets of high-energy particles stream outward from the vicinity of the merged black hole, carrying energy and enriched material throughout the galactic environment. The third movement of this cosmic symphony involves the final coalescence of the two galactic systems into a single unified structure. This process, unfolding over billions of years, creates what astronomers call an elliptical galaxy, a smooth, roughly oval distribution of stars that rotate in complex three-dimensional patterns rather than the organized circular orbits characteristic of spiral galaxies. This new galactic configuration is not less beautiful than its spiral predecessors, but differently beautiful, less structured perhaps, but more dynamically complex. As you float through the transformed galactic environment that results from this union, feel how the merger has created new opportunities for cosmic creativity. The gravitational stirring has brought together gas clouds that might never have encountered each other in the separate galaxies, triggering new episodes of star formation and the creation of stellar populations with unique chemical compositions. The increased stellar density in some regions creates new possibilities for planetary system interactions and perhaps enhanced opportunities for the development and exchange of information between civilizations. The combined galaxy, sometimes called Milky, in anticipation of this future union, will be larger and more massive than either of its parent systems, with a total stellar population exceeding 1 trillion stars. This vast stellar city will have a complex internal structure, with different regions characterized by different stellar populations, ages, and chemical compositions. Some areas will be dominated by ancient stars from the original galactic cores, while others will glow with the light of stars born during the merger process itself. For any civilizations that exist during this epoch of galactic transformation, the merger represents both challenges and unprecedented opportunities. The changing gravitational environment may disrupt some planetary systems, but it will also create new ones as stellar encounters redistribute matter throughout the combined system. The enhanced rate of star formation will provide new energy sources and new worlds for exploration and colonization. The night sky, as seen from worlds within the merging system, will be transformed beyond recognition. Instead of the delicate band of the Milky Way stretching across the darkness, observers will see a sky filled with stars and nebula, the increased stellar density creating a celestial dome bright enough to make nighttime nearly obsolete. New constellations will form from the combined stellar populations, and the patterns of stellar motion will become more complex and interesting, as stars follow elliptical orbits through three-dimensional space. The merger also creates new possibilities for cosmic engineering and large-scale construction projects. The enhanced gravitational environment may make it easier to build massive structures like Dyson spheres or ring worlds that harness stellar energy on unprecedented scales. The increased stellar density may facilitate interstellar travel and communication, as the average distances between potentially habitable worlds decrease throughout much of the combined galactic system. Yet, perhaps most importantly, the Milky merger demonstrates the universe's capacity for transformation and renewal even in its mature phase. Rather than simply aging and declining, cosmic structures can undergo metamorphosis that creates new forms of beauty and complexity. The union of galaxies shows that cosmic evolution continues to explore new possibilities even billions of years after the initial burst of structural formation that characterized the universe's youth. The gravitational waves generated during this merger process contribute to a new form of cosmic communication, carrying information about massive astronomical events across intergalactic distances. These ripples in space-time may provide a way for advanced civilizations to detect and study galactic mergers throughout the observable universe, creating a network of gravitational wave observations that spans cosmic distances. As you contemplate this destined union from your perspective floating peacefully through cosmic time, Notice how the merger represents a perfect balance between change and continuity. The individual stars and planetary systems that make up both galaxies continue their local evolution largely unaffected by the larger transformation, while the overall galactic environment undergoes dramatic restructuring. The universe demonstrates its ability to maintain local stability while enabling large-scale change and growth. The dark matter halos that provide the invisible scaffolding for both galaxies also undergo merger during this process, their gravitational fields combining to create a new dark matter distribution that will guide the future evolution of the combined system. This dark matter merger proceeds even more smoothly than the merger of ordinary matter, as dark matter particles interact only through gravity and can pass through each other without the complex electromagnetic interactions that affect gas and stars. The cosmic web of dark matter filaments that connects galaxy clusters throughout the universe continues to evolve during this epoch, with some connections strengthened by the merger process, while others are weakened by the ongoing expansion of space. The Milky-Way merger takes place within this larger context of cosmic structure evolution, representing one example of the ongoing transformation that characterizes the universe's continued development. As this magnificent dance approaches completion, you can sense the profound satisfaction that comes from witnessing a cosmic destiny fulfilled. The gravitational attraction between the Milky Way and Andromeda, established billions of years ago by the initial distribution of matter in the early universe, has finally overcome the expansion of space and brought these two stellar communities together in harmonious union. The resulting galaxy will be a testament to the universe's capacity for patient, long-term creativity. Every star in the combined system carries within itself the nuclear products of previous stellar generations, the heavy elements that make rocky planets and complex chemistry possible. Every planet that forms in the new galactic environment will be enriched with the accumulated gifts of billions of years of stellar evolution. Every consciousness that emerges will inherit the combined legacy of two ancient galactic civilizations. Joining, blending, becoming one, the rhythm of cosmic union establishes itself as individual galactic voices merge into a single richer harmony. The Milky-Way merger serves as a prelude to even larger future unions, as the local group of galaxies continues to evolve and coalesce under the patient influence of gravity. The universe demonstrates that its story is far from over, that new chapters of cosmic creativity and transformation await even in its mature phase. And as this galactic ballet reaches its crescendo, as two streams of starlight flow together into a single luminous river, you can feel the approach of an even more profound transformation. The merger represents not just the union of two galaxies, but a symbol of the universe's ongoing capacity for growth, change, and the creation of ever greater beauty through the patient work of time and the gentle persistence of natural law. The cosmos prepares to carry this lesson forward into its continuing evolution, confident that consciousness and memory will preserve the meaning of this magnificent dance across all the eons yet to come. Drift gently back now to the realm of human consciousness, to the miracle of minds that have emerged from cosmic dust, and learn to contemplate their own origins in the vast story we have been witnessing together. Here, on a small blue planet orbiting an ordinary star in the outer reaches of a typical spiral galaxy, something extraordinary has occurred. Matter has organized itself into forms capable of wonder. Consciousness has emerged that can trace its ancestry back to the first moments of creation, and intelligence has developed that can comprehend its place in the magnificent cosmic story that gave it birth. Picture our ancestors, those early humans who first looked up at the night sky with questions stirring in their newly evolved minds. They saw the same stars that shine above us now, the same moon tracing its patient path across the heavens, the same Milky Way streaming like a river of light from horizon to horizon. But they saw these wonders through eyes that had not yet learned to measure distances in light years, or to understand the nuclear processes that make stars shine. Their appreciation was immediate and intuitive, the simple awe of consciousness encountering the infinite. Around countless fires throughout human history, stories were told that attempted to make sense of the cosmic display overhead. Each culture developed its own mythology to explain the origins of stars and planets, the changing patterns of celestial motion, the meaning of comets and eclipses, and the occasional appearance of new stars in familiar constellations. These stories, while not scientifically accurate in our modern sense, represented humanity's first attempts to place itself within a larger cosmic context. Feel the profound continuity that connects those ancient storytellers to modern cosmologists and astrophysicists. The questions are fundamentally the same. Where did we come from? How did the universe begin? What is our place in the cosmic order? What will happen in the future? The tools for investigating these questions have become extraordinarily sophisticated, but the underlying human drive to understand our cosmic context remains unchanged. The development of agriculture allowed some humans to specialize in sky watching, creating the first systematic observations of celestial motions. Ancient astronomers in Babylon, Greece, China, India, and the Americas developed increasingly accurate methods for predicting eclipses, tracking planetary motions, and mapping the positions of stars. They discovered that the heavens, far from being chaotic, followed precise mathematical patterns that could be predicted and understood. These early investigations laid the foundation for one of humanity's greatest intellectual achievements, the recognition that the same physical laws that govern terrestrial phenomena also operate throughout the cosmos. Galileo's telescopic observations of Jupiter's moons demonstrated that other worlds could have their own satellite systems. Newton's law of universal gravitation showed that the same force that makes apples fall also keeps planets in their orbits around the sun. The invention of the telescope in the early 17th century opened new windows on cosmic reality, revealing details that had been invisible to naked eye observation. The phases of Venus confirmed that planets orbit the sun, rather than the Earth. The moons of Jupiter provided a model for planetary systems. The resolution of the Milky Way into countless individual stars suggested that our stellar environment was far larger and more complex than previously imagined. Each new generation of telescopes revealed deeper layers of cosmic architecture. William Herschel's discovery of infrared radiation showed that stars emit invisible light beyond the red end of the spectrum. The great refractors of the 19th century resolved nebulae into star clusters and revealed the spiral structure of galaxies. Photographic techniques allowed astronomers to capture light over long exposures, revealing faint objects that could never be seen through direct observation. The development of spectroscopy in the 19th century provided the key to understanding stellar composition and evolution. By analyzing the light from stars, astronomers could determine their chemical composition, temperature, and motion through space. This technique revealed that stars are made of the same elements found on Earth, establishing the fundamental unity of matter throughout the cosmos. Einstein's theories of relativity in the early 20th century revolutionized our understanding of space, time, and gravity, providing the theoretical framework necessary to comprehend cosmic evolution on the largest scales. General relativity showed that space and time are not fixed stages for cosmic events, but dynamic entities that can be warped by matter and energy. This insight made it possible to understand phenomena like black holes, neutron stars, and the expansion of the universe itself. The discovery of cosmic expansion by Edwin Hubble in the 1920s revealed that the universe has a history, that it was smaller and denser in the past, and has been growing and cooling over billions of years. This observation provided the first direct evidence for what would become known as the Big Bang theory, the scientific account of cosmic origins that forms the foundation for our modern understanding of universal evolution. Radio astronomy, developed during and after World War II, opened entirely new windows on cosmic phenomena. Radio telescopes revealed pulsars, quasars, and the cosmic microwave background radiation, that faint echo of creation that still fills all of space, nearly 14 billion years after the universe began. Each new wavelength of electromagnetic radiation provided unique insights into different aspects of cosmic evolution. The space age brought the capability to place telescopes above Earth's atmosphere, allowing observations across the entire electromagnetic spectrum from gamma rays to radio waves. The Hubble Space Telescope provided unprecedented views of distant galaxies, revealing the universe's history through direct observation of objects so distant that their light has taken billions of years to reach us. We literally see the past when we look at distant objects, making astronomy a form of time travel. Computational cosmology emerged as powerful computers made it possible to simulate cosmic evolution from the first moments after the Big Bang to the present day. These simulations reveal how dark matter, ordinary matter, and dark energy interact to create the cosmic web of structure we observe today. They show how tiny quantum fluctuations in the early universe grew into the galaxies and galaxy clusters that populate the modern cosmos. The detection of gravitational waves by LIGO and similar instruments has opened an entirely new sense organ for cosmic observation. These ripples in space-time, predicted by Einstein but not detected until 2015, provide direct information about some of the most extreme events in the universe. The merger of black holes and neutron stars that create conditions of temperature, density, and gravitational field strength that cannot be reproduced anywhere else. Modern cosmology has revealed that the universe is far stranger and more wonderful than our ancestors ever imagined. Dark matter, which comprises most of the matter in the universe, remains largely mysterious despite decades of investigation. Dark energy, which drives the acceleration of cosmic expansion, is even more enigmatic. These discoveries humble us by revealing how much we still don't understand about the cosmos that gave us birth. Yet perhaps the most profound discovery of modern astronomy is the realization that we are literally made of star stuff. The carbon in our bodies, the calcium in our bones, the iron in our blood. All of these elements were forged in the nuclear furnaces of massive stars and dispersed into space when those stars completed their life cycles. We are not separate from the cosmos, but integral parts of it, temporary arrangements of cosmic matter that have achieved the remarkable property of self-awareness. This scientific understanding does not diminish the sense of wonder that drove our ancestors to create mythologies about the night sky. If anything, the reality revealed by modern astronomy is more magnificent than any mythology ever imagined. We live in a universe that is 13.8 billion years old and contains at least 100 billion galaxies, each with billions of stars and potentially countless planets. The scale of cosmic reality dwarfs human imagination, while simultaneously providing the context that gives meaning to our existence. The search for extraterrestrial life represents one of the most profound questions emerging from our growing understanding of cosmic evolution. If life emerged on Earth through natural processes, acting on the elements created by stellar nucleosynthesis, then similar processes should be possible on countless other worlds throughout the galaxy. The discovery of exoplanets, planets orbiting other stars, has revealed that planetary systems are common throughout the cosmos. The development of astrobiology as a scientific discipline reflects our growing sophistication in understanding the conditions necessary for life and the possible forms that life might take on other worlds. From extremophile organisms in Earth's most challenging environments to theoretical biochemistries based on different solvents and energy sources, scientists are exploring the full range of possibilities for life in the cosmos. The search for extraterrestrial intelligence, SETI, represents humanity's first attempt to make contact with other conscious beings that may have emerged elsewhere in the galaxy. Radio telescopes scan the skies for artificial signals that might indicate the presence of technological civilizations. While no confirmed detections have been made, the search itself represents a profound expansion of human consciousness, the recognition that we might not be alone in our capacity for wonder and understanding. As you contemplate this magnificent journey of human discovery, notice how each generation has built upon the insights of previous generations, gradually expanding our understanding of cosmic reality, from ancient mythology to modern cosmology, from naked eye observations to space-based telescopes, from isolated human consciousness to the possibility of cosmic community. The trajectory of human understanding reveals an ever-expanding appreciation for the beauty and complexity of the universe. The tools of modern astronomy continue to evolve, with new generations of telescopes and detectors revealing ever deeper layers of cosmic reality. The James Webb Space Telescope provides unprecedented views of the most distant galaxies, showing us the universe as it appeared when it was only a few 100 million years old. Gravitational wave detectors are becoming more sensitive, opening new possibilities for detecting cosmic events that produce these space-time ripples. Future missions may detect biosignatures in the atmospheres of exoplanets, providing the first evidence for life beyond Earth. Advances in artificial intelligence and machine learning are accelerating the pace of astronomical discovery, allowing us to process vast amounts of data and identify patterns that would be impossible to detect through human analysis alone. Yet perhaps the most important aspect of humanity's cosmic journey is not the accumulation of facts and data, but the development of a cosmic perspective that places human existence within the context of universal evolution. We are not separate from the cosmos, but expressions of it. Matter that has learned to contemplate itself, consciousness that has emerged from unconscious processes, intelligence that can trace its ancestry back to the first moments of creation. This cosmic perspective provides both humility and significance to human existence. Humility, because we recognize how small we are in the vast scales of space and time that characterize cosmic reality. Significance, because we realize that consciousness and intelligence may be rare and precious phenomena in the universe, making every human mind a cosmic treasure whose capacity for wonder and understanding represents billions of years of evolutionary development. The future of human cosmic understanding is limited only by our curiosity and imagination. We may discover that life is common throughout the galaxy, leading to a rich community of conscious beings exploring the cosmos together. We may develop technologies that allow us to travel between stars, spreading Earth-originated consciousness throughout our galactic neighborhood. We may even learn to engineer cosmic processes themselves, becoming active participants in the ongoing evolution of the universe. But regardless of what specific discoveries await us, the fundamental human drive to understand our place in the cosmos will continue. Each generation will ask the eternal questions that have motivated human inquiry since our species first developed the capacity for wonder. Each generation will contribute its own insights to the growing human understanding of cosmic reality. Listening, learning, widening your gaze, the rhythm of human discovery continues as each new generation adds its voice to the ongoing conversation between consciousness and cosmos. We are the universe becoming aware of itself, matter learning to appreciate its own beauty, consciousness recognizing its cosmic ancestry, and contemplating its cosmic destiny. In our wonder and understanding, the cosmos finds a mirror in which it can see and appreciate its own magnificent complexity and beauty. And beyond the present moment, beyond current human understanding, lies the soft horizon of future discovery, where new questions will be asked and new insights will emerge. The cosmic story continues to unfold, and human consciousness continues to evolve in its capacity to appreciate and participate in the ongoing creativity of the universe that gave us birth and continues to nurture our growth toward ever greater understanding and wisdom. Drift now toward the most profound and peaceful epoch in the universe's long biography, the gentle twilight that awaits in the far future, when the cosmos will have completed its journey from the brilliant creativity of youth through the productive maturity of middle age into the serene wisdom of advanced years. This is not an ending, but a transformation into a different kind of beauty, like the transition from the vibrant colors of autumn into the crystalline purity of winter snow, where every form is simplified, yet made more elegant by the patient work of time. Picture the universe as it will appear trillions of years from now, when the expansion of space has carried galaxy clusters so far apart that each one exists in virtual isolation, surrounded by darkness broken only by the gentle glow of its own constituent stars. The Milky Way galaxy, that magnificent union we witnessed earlier, floats serenely in this vast ocean of space like a solitary island of light, its trillion stars shining with the accumulated wisdom of cosmic ages. The stellar population of this far-future galaxy consists primarily of red dwarf stars, those patient, long-lived members of the stellar community, that burn their hydrogen fuel so slowly and efficiently that they can maintain steady nuclear fusion for hundreds of billions or even trillions of years. These cosmic torches, each one smaller and cooler than our current sun, will be the last guardians of warmth and light in an increasingly cold and dark universe. Around these gentle suns, worlds continue to orbit in the familiar dance of planets around stars, though the cosmic environment has grown profoundly quiet compared to the dynamic activity of earlier epochs. The rate of star formation has declined to nearly zero as galaxies exhaust their reserves of gas and dust. No new stellar nurseries blaze with the light of massive young stars. No supernovas illuminate the darkness with their final gifts of heavy elements. The universe has settled into a rhythm of conservation rather than creation, making the most of the stellar resources that remain. Yet this is not stagnation but a different form of cosmic creativity, the deep creativity of consciousness that has had geological ages to evolve and explore the possibilities of mind and meaning. On worlds circling the long-lived red dwarf stars, intelligence has had trillions of years to develop forms of awareness and capability that transcend anything we can currently imagine. These far future consciousnesses may have learned to exist in forms that are not dependent on biological bodies, perhaps as patterns of information that can persist across cosmic time. Feel yourself floating peacefully through this era of cosmic contemplation, where the frantic pace of stellar birth and death has given way to the slow meditative rhythm of red dwarf burning. The background temperature of space has cooled to within a few degrees of absolute zero, yet scattered throughout the darkness, these ancient stars continue to provide islands of warmth, where complexity and consciousness can flourish. The black holes that formed through billions of years of stellar evolution have grown to enormous sizes, some containing the mass of entire stellar clusters. But even these gravitational giants are not permanent features of the cosmic landscape. Through the incredibly slow process of Hawking radiation, they gradually evaporate, returning their mass to the universe as elementary particles and energy. The larger the black hole, the slower this evaporation process, so the most massive ones will persist for periods of time so vast that they make the current age of the universe seem like a brief moment. As the last red dwarf stars exhaust their nuclear fuel, they do not explode or collapse dramatically, but simply fade away, cooling gradually from red to brown to black as their nuclear fires gently die. These white dwarf remnants continue to radiate heat into space, but at an ever-decreasing rate, their surface temperatures dropping slowly toward the ambient temperature of the cosmic background radiation. In this far future, the expansion of space has accelerated to the point where even photons of light are stretched to wavelengths so long that they carry almost no energy. The cosmic microwave background radiation, that ancient echo of creation, has been redshifted into invisibility, its temperature approaching absolute zero. The universe enters a phase of maximum entropy, where energy is distributed as evenly as possible throughout space. Yet even in this state of thermal equilibrium, quantum mechanics ensures that the universe is not completely static. Quantum fluctuations continue to create temporary variations in the vacuum of space, tiny bubbles of energy and matter that appear spontaneously and then dissolve back into the quantum foam. These fluctuations, while incredibly rare and brief, represent the universe's continued capacity for spontaneous creativity, even in its most quiescent state. The protons that make up the nuclei of atoms may themselves be unstable over these vast timescales, gradually decaying into lighter particles and energy. If this process occurs, even the white dwarf remnants of the last stars will eventually dissolve, their matter dispersed as individual electrons, positrons, and photons drifting through the ever-expanding void. The universe will have returned to a state somewhat similar to its very early moments, filled with elementary particles rather than the complex structures that characterized its middle age. But consciousness, if it has learned to exist in forms that transcend the specific physical structures of its early biological origins, may persist even through these ultimate transformations. Advanced forms of intelligence might learn to exist as patterns of information encoded in the quantum fluctuations of the vacuum itself, finding ways to maintain coherent thought and memory, using the minimal energy resources available in the far future cosmos. These hypothetical far future minds might experience time very differently than biological consciousness does today. With almost infinite time available and minimal energy to work with, they might operate at incredibly slow rates, with single thoughts requiring millions or billions of years to complete. Yet, from their perspective, these thoughts might seem to unfold at normal speed, allowing them to continue the cosmic conversation about meaning and purpose across timescales that dwarf the current age of the universe. In this ultimate future, memory becomes the most precious resource. The accumulated knowledge and wisdom of billions of years of cosmic evolution must be preserved and maintained, using the minimal energy available in an increasingly cold and empty universe. These far future consciousnesses become the universe's librarians, maintaining the record of everything that has happened throughout cosmic history. The stories they preserve include our story, the tale of how consciousness first emerged on a blue planet, orbiting a yellow star in a galaxy that once sparkled with the light of active star formation. They remember the first humans who looked up at the night sky with wonder, the scientists who decoded the mechanisms of stellar evolution, the civilizations that learned to work in harmony with cosmic processes rather than fighting against them. They remember the golden age when galaxies blazed with the light of billions of stars, when stellar nurseries gave birth to new suns at prodigious rates, when the heavy elements necessary for rocky planets and complex chemistry accumulated to optimal levels throughout the cosmos. They remember the era of galactic mergers, when separate stellar communities joined together in gravitational ballets that created ever more magnificent cosmic architectures. Most importantly, they remember the moment when matter first learned to contemplate itself, when consciousness emerged from unconscious processes and began the long journey toward understanding and wisdom that continues even in this far future. They understand that consciousness represents the universe's greatest achievement, the emergence of matter that can appreciate its own beauty, comprehend its own history, and find meaning in its own existence. As you drift through this eternal twilight, feel the profound peace that comes from understanding that consciousness, once emerged, may be able to persist even through the most extreme transformations of physical reality. The universe that began as pure energy and learned to become matter, that organized matter into stars and galaxies, that created the conditions for life and consciousness to emerge, may have succeeded in creating something truly eternal, minds capable of preserving meaning and beauty, even as the physical cosmos around them grows cold and empty. The music of the spheres continues even in this far future, though it has become incredibly soft and slow. The gravitational waves from the last merging black holes ripple through space-time at intervals of millions of years. The quantum fluctuations of the vacuum create subtle rhythms that conscious beings might learn to detect and appreciate. The expansion of space itself provides a cosmic heartbeat that connects all regions of the universe in shared participation in the ongoing growth of reality. In this ultimate state of cosmic rest, the universe may finally achieve the perfect balance between order and chaos, structure and freedom, that philosophers have long sought. Every possible form of organization has been explored. Every potential for complexity has been realized. Every question that can be asked has been investigated. The cosmos settles into a state of complete fulfillment, having exhausted all possibilities for growth and development. Yet even in this state of completion, the universe retains its essential character, the capacity for creativity, beauty, and meaning that has driven its evolution from the first moment of existence. The consciousness that emerged during the universe's Middle Age continues to explore the implications of existence, to find new forms of beauty in the most subtle phenomena, to discover meaning in the very fact that something exists rather than nothing. Perhaps in this far future, consciousness learns to create entirely new universes, spawning baby cosmos that recapitulate the evolutionary journey we have witnessed, but with variations that explore new possibilities for cosmic creativity. These new universes might experiment with different physical laws, different constants of nature, different ways of organizing matter and energy into complex structures. Or perhaps consciousness discovers that it can directly manipulate the quantum vacuum, creating new forms of matter and energy that transcend the limitations of the current physical universe. Advanced minds might learn to engineer space-time itself, creating pocket universes where different forms of complexity can evolve and flourish. But regardless of what specific possibilities await in the ultimate future, the essential message of cosmic evolution remains constant. The universe is not meaningless matter, wandering through empty space, but a creative process that tends toward the emergence of consciousness, beauty, and meaning. We are not accidents in an indifferent cosmos, but expressions of the universe's fundamental drive toward self-awareness and self-appreciation. As this cosmic lullaby draws toward its close, feel yourself returning gently to the present moment, to your own place in the ongoing story of universal evolution. You are the universe becoming aware of itself, matter learning to contemplate its own beauty, consciousness recognizing its cosmic ancestry and cosmic potential. In your wonder and appreciation, the cosmos finds fulfillment for its long journey from unconscious energy to conscious spirit. The night sky above you, should you open your eyes and look upward, contains the entire story we have shared together. The light of distant stars carries the history of stellar evolution. The gentle glow of the Milky Way traces the gravitational architecture that has organized matter into galactic communities. The darkness between the stars hints at the vast scales of space and time that provide the canvas for cosmic creativity. You are connected to all of it, to the first moment of creation that began this entire journey, to the stellar nucleosynthesis that forged the elements of your body, to the planetary processes that created the world you inhabit, to the biological evolution that gave rise to consciousness itself, and to the far future when advanced minds will remember and celebrate the emergence of awareness in the cosmos. Fading, softening, resting in eternal calm, the rhythm of cosmic breathing continues as the universe settles into its final state of peaceful contemplation. Yet this is not truly final, for consciousness once emerged can find ways to persist and continue the cosmic conversation about beauty, meaning and purpose across any span of time, through any transformation of physical reality. Sleep now in the knowledge that you are part of the greatest story ever told, the biography of the universe itself, the tale of how energy learned to become matter, how matter learned to become complex, how complexity learned to become conscious, and how consciousness learned to find meaning and beauty in its own existence. Rest in the understanding that your capacity for wonder connects you directly to the creative processes that have been unfolding since the first moment of time. And as you drift into sleep, remember that the cosmic story continues. Each day brings new discoveries about the nature of reality. Each generation adds its own insights to the growing human understanding of our place in the cosmos. Each moment of conscious appreciation adds to the universe's ongoing process of self-discovery and self-celebration. The stars will continue to shine, the galaxies will continue their ancient dances, and consciousness will continue to find new ways to appreciate the magnificent reality that gave it birth. In your dreams and in your waking moments, you participate in this ongoing creation, this eternal flowering of cosmic beauty and meaning that began with the first whisper of existence, and will continue as long as minds exist to contemplate the wonder of being. Sweet dreams, fellow travelers in the cosmic journey. Rest peacefully in the knowledge that you are the universe dreaming of itself, consciousness exploring its own infinite depths, love discovering its own eternal nature. The cosmic lullaby continues, soft and eternal, carrying you gently through the night toward new dawns of understanding and appreciation. You are home in the cosmos, and the cosmos is home in you, forever and always, in this eternal dance of consciousness and reality, meaning and being, love and infinite possibility. As you drift deeper into peaceful sleep, I'm curious, which aspect of our cosmic journey sparked the most wonder in your mind tonight? Was it the gentle flowering of the first stars from primordial hydrogen clouds, the magnificent dance of galactic mergers that created ever more complex stellar communities? Or perhaps the profound realization that you are literally made of ancient starlight, conscious matter contemplating its own cosmic origins? Share your thoughts in the comments below, and let's continue this universal story together. If this cosmic lullaby helped you discover something new about our place in the universe while finding peace, consider subscribing for more journeys through the vast scales of space and time. Tomorrow night, we might explore the hidden lives of stars, the secret architecture of galaxies, or the possibility that consciousness itself represents the universe's greatest evolutionary achievement. Sweet dreams, fellow cosmic travelers. Remember, you are stardust with consciousness, ancient light that learned to love, the universe experiencing itself subjectively through your capacity for wonder and appreciation. Rest peacefully in your cosmic home.